what makes up things are not more things, but what makes up things are ideas, concepts, information.
And like I said, it never touches.
Another strange fact is that objects never really touch each other. When I dribble this ball, the atoms of the ball and the atoms of the ground never actually meet.
So nobody touches nothing. Come on, put your stuff down. Nobody's gonna take it. Like I said, this is my court. It's no problem. How long has it been?
I'll be 8.
The first inkling in physics that we got that time ain't what it seemed to be came with relativity. That was the first inkling that time was not absolute. It was not the absolute ruler of the universe, that God Almighty did not say 1 second, 1 second, 1 second, 1 second, 1 meter, 1 meter, 1 meter, you're in a gravitational field. Your head is actually moving at a slightly faster rate than your feet.
The second law of thermodynamics says that things unwind and move forward, so that gives an arrow of time. But at the quantum world, in the micro world, the second law of thermodynamics doesn't seem to hold, and things can go backwards or be timeless.
The fundamental equations of physics have a property which is referred to as time reversal symmetry. And what time reversal symmetry means is that a set of laws, which are time reversal symmetric, are laws that have the following feature. For any process that's in accord with those laws, the same process going backwards is exactly as much in accord with those laws, okay? That ought to mean that that milk jumps out of coffee as often as it dissolves into it, that people get younger looking as often as they get older looking, that we have the same kind of access vis-a-vis knowledge to the future as we do to the past, that by acting now we ought to be able to influence the past just as much as we can influence the future. All of that is wrong. All of that comes into violent conflict with the way we psychologically experience the world.
One of the most unpalatable ideas still, in spite of the fact that quantum physics has been around a long time, is the possibility or the notion that the future can have a causative effect on the present. We believe that the past can have a causative effect on the present. I hold the ball, I drop it, it falls. Cause, effect when it hits the ground. But could the ground be the cause of my dropping the ball in the first place?
It's only in conscious experience that it seems that we move forward in time. In quantum theory, you can also go backwards in time, and there's some suggestion that processes in the brain related to consciousness project backwards in time. For example, in the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet did some very famous experiments. What Libet did was study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex. Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When he stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay. After sorting through all the data and repeating this over and over, Libet came to the conclusion that somehow the brain was projecting information backwards in time, so that it did take a finite amount of time to get to the sensory cortex, but the brain projected it backwards in time so that the conscious perception was that the stimulus was felt when the pinch actually occurred.
There have been some studies which have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain in certain nerve cells of the brain, even before they become consciously aware of what they're trying to do.
I know it seems to me that I often do things and then decide a fraction of a second later what to do, but I've already done them.
I'll be late.
You can always go back in time. What's the matter? Remember, it's empty.
How do you know this yet?
I read Dr. Quantum comics. Everybody thinks it's just kid stuff, but I know it's real. That's how I do my magic on the court.
So, what they taught us in school isn't really the way it is, and that our senses are playing tricks on us. You just gotta wonder, what is this reality that we find ourselves in? Quantum physics says it's all just waves of information. Do I believe that? I hope so. Yikes!
That's how I do my magic on the court.
Yeah, I always choose the Wonder Boy first.
Well, Dr. Quantum says everybody's got it. Everybody's doing it constantly, each and every time you look.
And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits, and it goes through neither. And it goes through just one, and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of 2 bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange netherworld of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
We are always the observer. But sometimes we identify with the event so much so that we even lose the aspect of the observer. That's why the materialist gets totally lost and thinks that we could do without the observer.
The physics data tells us that, that an object itself is really a simplification for what we call out there. One is particularly when we're looking at atomic and subatomic particles, or atomic and subatomic matter in any form. What we find is how we go to look at it, what we choose to examine it with, actually changes the properties of what we observe to be out there.
Is this the observer, and which is so intricate to understanding the wacky, weird world of quantum particles and how they react? Is this, then, the observer? And even though we cannot have a quantum field without the observation of scientists who have gone there, who have uncovered it, layer after layer after layer, they're all observers. But not one of them agree conclusively on all points in the field, because they are perceiving the field mathematically from different angles of perception.
We don't know in quantum mechanics how to hook ourselves as observers up with the world. We don't know how to treat ourselves as observers as just another part of the physical system that we're describing. The only way we know how to do quantum mechanics as it's traditionally formulated is to keep the observer outside of the system you're describing. The minute you put him in, you get all these paradoxes. And we're forced to say things in quantum mechanics like, look, the book is doing what it's doing because of quantum mechanics, and I see that because I'm there and I see it, and you better not try to analyze that second part of the sentence in terms of applying quantum mechanics to it, because it's going to break down. That's why there are these 2 separate laws of the evolutions of physical systems. One that applies when you're not looking at them, the other that applies when you are. But that's crazy.
There's no way that we're ever going to mathematize or put into mathematical formula this very act in which a conscious observer comes up with the answer. People say, oh, the measuring instruments, the recorder records it, and there it is, it's on the tape, it's recorded. You forgot one part of the equation. Somebody has to look at the tape. And until somebody looks at the tape, it ain't recorded at all.
When you are not looking, there are waves of possibility. When you are looking, then there are particles of experience.
A particle, which we think of as a solid thing, really exists in a so-called superposition, a spread out wave of possible locations. And it's in all of those at once. The instant you check on it, it snaps into just one of those possible positions.
It's easy to generate situations where the equations of motion will predict that, say, the wave function, the psi of a certain basketball, is uniformly distributed all over the basketball court. We don't have any idea what a state like that would look like. According to the law of quantum mechanics, that's supposed to be a state in which it fails to make any sense even to ask the question, where is the basketball? That is, according to the law of quantum mechanics, asking the question, where is a basketball whose psi is uniformly distributed over a whole basketball court, is the logical equivalent of asking about, say, the marital status of the number 5. Okay? It's not that you don't know the answer, you don't happen to know whether the number 5 is married or a bachelor. It's that the question somehow is radically inappropriate in the first place. The number 5 doesn't have a marital status, there's nothing there to ask about, and similarly, a basketball whose wave function was uniformly distributed over the entire basketball court would not have a position that could even coherently be asked about. Now, the crux of the measurement problem is precisely that, although the Schrodinger equation predicts under certain circumstances, circumstances which we basically know how to reproduce in the laboratory, that basketballs should go into states like that, states where there fails to be any intelligible fact, any sensible question even about where they are. And yet, when we go look at the basketball court in situations like that, we invariably see either a basketball over here or a basketball over there or a basketball over there. The fact that we see the basketball in some specific location, as opposed to seeing it in some science fiction state that we can't even imagine what it looks like, where there fails to be a question about what its location is, the fact that we always see it in some definite location is an explicit violation of these equations of motion, and it's exactly there that the measurement problem comes up.
When you observe, things happen. When you don't, they don't.
Superheroes use superposition, with the world being potential strips of reality. Until we choose. Heroes choose what they want. Being in many places at once, experiencing many possibilities all at once, and then collapsing on the one. The question is, how far down the rabbit hole do you want to go?
Your own mind is creating multiple possibilities in your subconscious. The superpositions of possibilities are in your subconscious. I mean, you may be consciously aware of them, but they exist, I think, in superposition of multiple possibilities, which after a while will collapse to one or the other.
Project or plan into the future or cast a thought ahead of itself.
Nice shot.
But the great-great-granddaddy of wacky quantum weirdness is entanglement. If time reversal symmetry destroys the notion of time, then entanglement crushes our experience of space. Two objects, two electrons created together, are entangled. Send one to the other side of the universe. Now, do something to one, and the other responds instantly. Instantly. So, either information is traveling infinitely fast, or, in reality, they are still connected. They are entangled. And since everything was entangled at the moment of the Big Bang, that means everything is still touching. Space is just the construct that gives the illusion that there are separate objects. Are we far enough down the rabbit hole yet?
You now can see in numerous labs around the United States objects that are large enough to be seen by the naked eye, and they are in two places simultaneously. And you can actually take a photograph of that. Now, I suppose if you showed a photograph, they'd say, oh, great, here's this nice blob of colored light, and I see there's a bit of it over here and another bit of it. So you got a picture of two dots. What's the big deal? Superposition is pre-detection. What I was speaking about in the film is post-detection. Now, under normal circumstances, a single object, once it has been detected, is in just one position. However, there are states of matter that have been created now in which objects can be in multiple positions simultaneously, not just two, but actually as many as 3,000 positions. The first of these objects were called Bose-Einstein condensates. And they are single wave functions, meaning they are single particles. But even though they're a single wave function, the wave function has multiple positions. And if you say, well, look right in the chamber. You can see it right there. Oh, I see two things there. You say, no, that's not two things. That's one thing. It's the same thing in two places. Tricky point here is that it's still a single wave function. It's not 3,000 separate wave functions. It's one wave function. So it's one particle. I'm not sure that people's jaw would drop about it because I don't think people really believe it. And I don't mean that people say, oh, you're lying, or oh, the scientists are confused. I think it is so mysterious that you can't even understand how amazing it is. One particle in 3,000 different locations.
Now, if you were to weigh one of them, would it weigh 1/3000th?
Well, you can't weigh one of them.
Why?
Because it's one particle. It's one indivisible particle.
But if it's in different locations, can't you put a scale under one?
No, it's inseparable. It's not this is the tricky conceptual part that it's not 3,000 separate parts.
Even though it looks that way.
Right. You can look at it, and I mean, you can't actually see the one with 3,000, but you can look at the simpler ones, the ones that are 2 or 3 or 4, and you can see, as I say, if you go onto the web, you'll see photographs of these. You'll see these little dots floating in space, and these are the different parts of one object. They're not separable. It's not 4 different objects or 6 different objects. It's one wave function. It's one object.
That's a real brain fart, isn't it? Because when you think about it, you just, well, wait a minute, no, they're like here, here, here. So it's obviously 1, 2, 3.
No, you can't, and you can't pull one away from the others. If you try to pull one away from the others, the entire thing will just disappear. And then furthermore, you've seen Star Trek and whatnot. Beam me up, Scotty.
Beam me up, Scotty.
So it all seems sort of, oh, well, what does that really mean? But you've got to really stop and think about what that means, that it's the same object and it's in 2 places at once. And people tinker in the lab and they get angry about things and they have lunch and they go home and they lead their lives just as though nothing utterly astounding is happening, because, of course, that's how you have to go about it. And yet there is this completely amazing magic sitting right in front of your eyes.
We took 2 simple black boxes like this. Inside is a very simple electric circuit with a few diodes, oscillator, EEPROM, some resistors and capacitors. Basically, that's it. We wrap one in aluminum foil. We put it in an electrically grounded Faraday cage. The other we set on a tabletop around which 4 very well qualified meditators, highly inner self-managed individuals sit. And they go into a deep meditative state. They cleanse the environment. They make it essentially a sacred space using their mind cleansing procedures and their intentions. And then one of the four speaks the specific intention for this device. The intention is to influence a particular target experiment. Might be to increase the pH of purified water by 1 full pH unit, or to decrease the pH by 1 full pH unit. We've used these devices on all those experiments and have been robustly successful. In the meditative process, then after one speaks the particular intention, it's held various ways by the four for maybe 15 minutes, and then so be it, it's let go. And then a subsidiary intention is stated to seal that imprint into the device. We take one of these devices with its aluminum foil, we put it in a soft package, we put it in a FedEx packet, we ship it 2,000 miles away to the laboratory we were using up in Minnesota. And as soon as it arrives there, it goes into its own electrically rounded Faraday cage. The next day we do the same with the control. The experiment is running, and basically then one just takes the device out, sets it beside the experiment within 6 inches to a foot, and turns it on for a period of time. That's it. Now, we learned over some period of time that there was another factor. We found that the use of these, we call them intention imprinted electrical devices, the continued use of this somehow conditions the space to some higher level of symmetry. And we start getting new phenomena. That is, the devices work. That is, the pH, which is normal, starts rising 1 full pH unit, if that was the imprint, or starts dropping. If you go 1 full pH unit or beyond, you're dead. I mean, that's what it means to a human.
REG machines, random event generators, are electronic tosses of the coin.